Consider the word Mississippi. Determine all the permutations of the letters in which the four S's must be together. So here's our word Mississippi, but we are given the condition that the four S's must be grouped together. One possible case of the four S's being grouped together could look like having the four S's at the very start of the word Mississippi, and then the remaining letters following that. We could also consider another case where the four S's are after one possible letter. And we could repeat this pattern, putting the S one location to the right in the word until we end up with the case where we have all 7 of the letters first, and then the 4 S's at the very end. This means that there are 8 different places where we could put the 4 S's. Now, we'll come back to this in a little bit. To figure out this question, we can use the equation that looks at the possibilities for some permutation of letters. And the equation is n factorial, where n is the number of options, divided by any duplicates that we might have. A factorial, b factorial, etc. if we need it. So looking at the word Mississippi, to determine what n is, if we didn't have the condition where the 4 S's would be together, it would be 13, the number of letters in Mississippi. But we are not considering that case because we are looking at just the number of permutations of these 7 letters that go in some order for one of those cases. That means that n is equal to 7, so 7 factorial. And we divide it by any possible duplicates that might arise. Ignoring all the S's in our word Mississippi, we can see that there are some duplicates. M is unique, but we have 1, 2, 3, 4 I's. And so we're going to divide by 4 factorial to account for those duplicates. We're also going to divide by 2 factorial to account for the 2 letter P's. If we go through and do this calculation, 7 factorial divided by 4 factorial divided by 2, we end up with 105 different possibilities. Though that's just looking at the possibilities for this case here, when in reality there are 8 different cases because the S's could be placed in 8 locations. So we need to take 8 and multiply it by the number of possibilities we found, 105, to find the true number of permutations. And that ends up being 840.